Okay, so these ones we're using the unit circle to evaluate without using a calculator. So the tangent of pi over 4. So we just go on the unit circle. We find pi over 4. Now, I know it's kind of hard for y'all to see it on the screen, but the tangent values are outside. So the tangent of pi over 4 is going to be 1. (22) secant of pi over 3. Now, are secant values directly written on the unit circle? No. But secant relates to what other trig function that is on my unit circle? Cosine. So I'm going to treat this as 1 over the cosine of pi over 3. Now the cosine of pi over 3. Oh, wrong thing.
Ooh, that is that the square root 3 over 2?
Cosine or x values.
Oh, then 1 over 2.
Cosine's x value, sine is y. Alphabetical order. So cosine is 1/2. I don't know why it keeps doing that. So this is 1 over 1/2, which obviously when you divide by a fraction, we multiply by the reciprocal, so it's 1 times 2 over 1, or just 2. (24) cosecant of pi over 3. So is cosecant directly written on our...
No.
But what trig function? Yep. So it'll be the same thing, 1 over the sine of pi over 3. Sine of pi over 3 was what?
Square root of 3 over 2.
Square root of 3 over 2. So it's 1 over the square root of 3 over 2.
So it'd be 2 over... Oh, wait.
So we would multiply, we would flip it, so it would be 2 over the square root of 3, but we can't leave it that way, so what does that give us?
2 square root of 3 over 3.
Yep, 2 square root of 3 over 3. If, just hypothetically, if anything ever can cancel, make sure you cancel it down, obviously, but...
Like if there was a 2 on the bottom.
Yeah. Which isn't necessarily like overly likely to happen, but it can. More so with cotangent, you'll see it happen because of the way that the square roots are. Because cotangent's opposite of tangent, so. Okay. So that was for radians. Now the next one, say to evaluate using a calculator, but if they're known values on the unit circle, you are not allowed to use a calculator for them. So these next ones are going to be known values. Then the section after that are going to be you have to use a calculator for them because they're going to be like the tangent of 74 degrees. Well, we don't know that, so you have to use it. But so 26, the sine of 60 degrees would be what?
Oh, I know that one. Square root of 3 over 2.
Yep, so 60 degrees is the same as pi over 3. Sine is y, so square root of 3 over 2. And then why not? Apparently they really like the pi over 3s and the 60 degrees today. 28, the tangent of pi over 3 would be what?
Square root of 3.
Yep, square root of 3.
Square root. Oh my gosh. It's not coming to my head.
Radical.
Yeah, I was about to say that. But I was
All right, the next ones are using a calculator. So
Yeah.
30 We have the tangent of 8 degrees. Now remember to check the mode that your calculator is in, okay, because these problems are going to alternate between degrees and radians, so make sure you look and have it in the right mode, but you need to be in degree mode for this one. And it says to go out to 3 decimal places, so we'll just roll with that. .141. Let's see, 34, the sine of pi over 15. Now that's in radians, okay? The pi indicates that it's in radians. So switch to radian mode. Let me specify. If there's a pi or no units listed, it's in radians. Okay, so if it doesn't have a degree symbol, assume that it's in radians. One of the problems has the minutes in it, which would mean you have to convert like we were doing in the first section. But I'm probably not going to give you one like that, just because if you can prove to me in 4.1 or whatever it was that you can convert degrees, minutes, and seconds to decimals, there's no reason for me to have you do it again in this problem. So. 0.2, oops, wrong color. 0.208. And let's do one more. 38 secant of 1.24. So there's not a secant button on your calculator, so that means we need to treat it as what? 1 over cosine of 1.24. Now, no degree symbol, so that means it's in radians, so leave your calculator in radian mode when you type that in. So then what is that? Yep. All right, the next one, say to find the acute angle. Notice it says acute, means what? Less than 90 or less than pi over 2 if we're in radians. That satisfies the given equation. Give theta in both degrees and radians. You should do these problems without a calculator. So again, that means with the unit circle. So 42, we have the sine of theta is equal to the square root of 3 over 2. So we go over to our unit circle. Where is sine of theta equal to the square root of 3 over 2?
Pi over 3.
Pi over 3. So again, the reason I pointed out acute is because it also occurs at 2 pi over 3 or at 120 degrees. But that's not an acute angle, so I want the pi over 3 one. So it's pi over 3 and 60 degrees for those. So it wants you to write both. So pi over 3, 60 degrees. 44 cosine of theta is equal to square root of 2 over 2. So where's cosine square root of 2 over 2? That's acute. Pi over 4 and 45 degrees. All right, this next one, 46. Cotangent of theta is equal to 1. So cotangent is 1 over tangent. So basically, where is tangent of 1? 45 degrees or pi over 4. So if it gives you like cotangent, secant, or cosecant, just know that you just need to flip whatever it's equal to. Just flip it. Like if it's already a fraction, then obviously flip it over, and that'll give you what the value for its buddy trig function is. Okay. So then solve for the variable shown. So it's a triangle that is something like this. Now they're not specifying that it's a right triangle, so don't make assumptions. Only use what is given to you. So what trig function associates the pieces that are given to you? That's fine.
Okay, can you ask that again?
Yeah, so what trig function associates these three things that are given to you?
Cosine.
Cosine, so cosine of 39 degrees is equal to adjacent, so it's 23 over hypotenuse z. Then I can flip z in 39 degrees because essentially I'm multiplying by z divided by cosine of 39. So z is equal to 23 cosine of 39. And remember that's in degree mode. If you were still in radian mode from the last problem you did, make sure you switch it back. And just go to the nearest whole number for these ones.
18.
18. I'm going to do one more of these just because it's kind of weird the way that it's drawn for you. Now this one does specify a right triangle by putting the little square in the corner. But you're given this angle here is 66 degrees, and then you're given this side and the hypotenuse value. So which trig function associates those values?
Is it cosine?
It's still cosine. So it'll be the cosine of 66 degrees equal to adjacent, so x over hypotenuse 50. So then I can just multiply by 50. So x is equal to 50 cosine of 66. So these ones are basically just working you up to the next set of problems where we're solving for everything. So, which I think are sometimes a little bit easier. 20. All right, so then the last problems here, which if you need me to do more than one of them, I can. It's going to basically look like that problem that you see on the board over there from Algebra 2. It's basically what we're doing. We're solving for all the sides and all the angles. So they go ahead and tell you, we're going to do 56. They go ahead and tell you that the triangle looks like this. It is a right triangle. This is angle C, angle A, angle B. So then side A, side C, and side B. Now, they're calling these angles in here, they actually label them as beta and alpha, but I would just call them angle A, B, and C. They do that because when they get to the double and half angles that we did last year, that everyone hates, they do it so it's like you're already used to. I don't do that. Minor details. All right, so then they're going to tell you two pieces of the triangle, and we need to solve the other ones. So I'm going to go ahead and set up. I always do angles and sides over to the side because even the stuff that's given, I want you to go ahead and write in. That way you make sure you find all 6 pieces that are given to you. So they tell us that, okay, alpha, angle A, is 41 degrees. And they tell us that side C is 10. Now, what's something else just visually that we see? Because that's all they actually give you.
Well, angle C is 90 degrees.
Angle C is 90 degrees. So that's just given to us because of the box.
And
Okay,
then-
the previous problems that we did, number 50, they did not draw a box, so we cannot assume it was a 90-degree angle. Okay.
And then since we have both those two angles, we can get the.
Yep, we can solve for the other one. How?
Because,
Or how many let me do this. How many degrees make up a triangle?
180.
180. So to do angle B, we'll do 180 minus 90 minus 41, which will be what?
49 degrees.
49 degrees. Now, sometimes I will go in, I will write in, as I fill in things over here, I'll actually put them on the triangle just so that I can see them. So if you're kind of a visual person like me and you want to do that, that's fine. So I usually go ahead and do it just for the sake of having it. So I need to find side A and side B. So what is something that I have that I can use to find side A? What trig function do you want me to use to find side A? Cosine of what angle?
Angle B.
Cosine of angle B. So I'm going to do the cosine of 49 degrees is equal to adjacent A over hypotenuse is 10. So then I just need to multiply by 10. So A is equal to 10 times the cosine of 49. Make sure your calculator's in degree mode. I know it's going to get repetitive me saying that, but people mix their calculator up or have it in the wrong mode all the time, so.
How many decimals?
We're just going to go a whole number.
100?
Yep.
7.
7. I'm going whole number because when we get to law of sines and law of cosines, it makes things easier if we go ahead. Because that way, if everybody always does nearest whole number, it doesn't affect answers being off so much when we get to that. So I'm just going to say get used to it and just do nearest whole number for these. And then side B. There's a couple things you could tell me to do here to find side B. So
I think the best thing to do would probably we could do cosine of angle A. Could we do
cosine of angle A. Yep, that's an option we can do.
Because it'd probably be better to use the given instead of.
Yeah, I always, and so that's something I was trying to get Algebra 2 used to, but to use the given values if possible, especially when it's not as big of a deal when we're here because, like, technically angle 49 was a value that, or angle B being 49 was a value that we found, but that should be a pretty easy, that shouldn't be a value you have to worry about. When we get to side lengths, I try to use the ones that were given in case something was wrong. Let's say hypothetically you forgot to change your calculator's mode or something like that. You're not going to get it like way off. So the cosine of 41 degrees is equal to B over 10. So B is equal to 10 cosine of 41. Which is 8. Now, another option, since we know it's a right triangle, we could have used the Pythagorean theorem. I usually don't with these just because I think it takes more work than just setting up a trig function and typing it in your calculator. And then the other thing we could have done, like the sine of angle B and done B over 10, then that's another option. So there's a lot of different things you can do. Technically speaking, we could have also done tangent of B since we had found A, but like I said, try to refrain from that because this is a found value, and if I did something wrong, then I'm not, completely messing it up. But do we feel like we need to see another one of those? Yes. Okay. Yep, we can do that. So then 58 So it'll be, I'm going to go ahead and redraw the triangle just so I can fill it in again. But it's going to always be the same triangle for these problems. They're giving it to you. So C, B, A, and then little c, little a, little b. All right, and then I'm going to set up my pieces over here. All right, so they tell us that side A is 5 and angle B is 59 degrees. Now, we said last time we know angle C because it's given to us in the picture is 90 degrees. So to find angle A, I would be doing what?
180 minus the 9 plus 50.
So minus 90 minus 59.
31.
So 31 degrees would be angle A. So I'll go ahead and fill in this stuff that I know here. Again, you don't have to fill it into the actual triangle, but you do need to write it, like listing out all 6 things. Don't make me go searching for it. But filling in the triangle is just for you. If you're a visual person, I tend to do that myself. So, all right, so which trig function and which angle should I use to find side B? Or which one do you want me to use?
We could use the tangent of C.
I can't use angle C
Oh, we can't?
because 90.
Oh, you
You
can't
can
use the
tan
90.
59.
The tangent of 90 is undefined. Huh?
You can do tangent of 59.
Yeah, I can do tangent of 59. So the tangent of 59 is equal to b over 5. So then b is equal to 5 tangent of 59.
Equals 8.
So that's 8. And then how about finding c?
Cosine of 59.
Cosine of 59 is equal to adjacent over hypotenuse, so 5 over c. So I can swap c and cosine of 59. So c is equal to 5 divided by the cosine of 59. So then that's everything that you need for that. Any questions about these? All right, then let's see. I gave you a few problems the other day, right?
Yes.
Okay. All right. This is going to look like a lot of problems, and it kind of is, but I want you to get used to using your unit circle. So they shouldn't take you a long time because it's just reading off the unit circle. What I would almost do is write down what all the problems are and then just use your unit circle and just answer them all then, personally. All right, so without a calculator is going to be 19, 21, 23, 25, and 27. With a calculator is going to be 29, 33, 35, 37, and 39. And then the other problems that basically, well, it's also technically without a calculator, but it's just, again, reading off the unit circle, is 41, 43, 45, 47, and then some of the triangle problems, I'm going to give you 2 that it's like already set up for you and you're just finding the one piece, so 51 and 53, and then only 1 where you have to find everything, 57. But 55 is also one that you have to find everything, so if you feel like you need some extra practice, that's fine. So the only ones you really have to do work for that aren't just reading off the unit circle are these last 3. The rest of them are all just off the unit circle.
Just this one. 3, 11, 15.
So...
Knock some of these out.